Hello friends, in last lecture we have seen indices of sides, indices of direction, and we also seen the equivalent direction. What is equivalent direction? We know that in a crystal there exist an infinite number of families of direction. Out of these there are set of direction having identical spacing. There are set of directions having identical spacing between the atoms. Identical spacing between the atoms are called equivalent directions. Okay. This family of directions are represented by the angle bracket. That is like this. That is angle bracket. That is like this. That is SQL is shown here. These are the parameters which are represented inside the angle bracket. Therefore, this represents the family of direction. Let us consider the family of direction. We had considered a family of direction that is 100. Now in the cubic crystal, what is 100? That is 1 means along x-axis. Therefore, this direction represents the along x-axis. This direction represents the direction 100, which is represented in the square bracket. Okay. Now, according to definition, in equivalent direction, there are set of directions having identical spacing between the atoms. Therefore, let us consider this. We had considered this is the origin. Along this direction represents the 100. This is the lattice side. And this is the nearest atom to this origin. Similarly, if we consider this is the cubic crystal, it means that this atom must be at the same distance. Like this, because it is the cubic crystal. Therefore, according to definition, there are set of direction having identical spacing between the atoms. Therefore, the family of direction 100. Under this family comprises 100 direction, that is this direction, that is minus 100. It means that the negative direction of this, because there is also the unit cell, and there is also lattice side which is at the same distance as like this distance. Therefore, minus 100. Therefore, 010, that is it is along y-axis. It means that this direction represents the 010. Therefore, this is direction 010. Opposite to this direction, त्या ठिकाणी सुद्धा एक युनिट सेल असेल, त्या ठिकाणी तेवढ्याच डिस्टन्सवर एक ॲटम असेल जेवढ्या डिस्टन्सवर एक्स पॉझिटिव्ह डायरेक्शनला आहे. म्हणजे या ठिकाणी झिरो मायनस 10 आणि त्याच पद्धतीने झेड डायरेक्शनला दॅट इज दिस डायरेक्शन इज 001 आणि त्याच्या निगेटिव्ह डायरेक्शनला 00-1. That is this represents the family of this direction. Family of directions. Similarly, let us consider the family of 110. Now, what is the direction 110? That is 11. That is x-axis, y-axis, and z-axis is 0. That is 110. It means that the direction must be 110. Means that along x-axis, y-axis, and z-axis should be 0. That is this point, this lattice side. That means that this direction must be the direction 110. Therefore, the family of this 110 must be, first is 110, second is याच्या निगेटिव्ह डायरेक्शनला, that is minus 110. त्यानंतर थर्ड इज 1-10, that is y-axisला निगेटिव्ह डायरेक्शनला. त्याच पद्धतीने या दोघांचा -1 त्याच्या अपोजिट डायरेक्शन, या डायरेक्शनच्या एक्झॅक्टली अपोजिट डायरेक्शन. ठीक आहे. तर त्या तेवढ्याच डायरेक्शनला तिथेच ॲटम असणार आणि तेवढ्याच डिस्टन्सवर असणार. आणि अकॉर्डिंग टू दिस डायरेक्शन, अकॉर्डिंग टू डेफिनेशन, डायरेक्शन हॅव्हिंग द आयडेंटिकल स्पेसिंग बिटवीन द ॲटम्स. Therefore, another is 101, -101, 00 -1, -1, and third is 011, 0-11, 01 -1, and 0 -1. This comprises the family of this. So you can find out the family of this. Try to find out the family of this direction. That is how many directions are comprises in this family. You have to just try to find out this. Now, next topic is indices of planes. Indices of lattice planes. Yeah. We know that in a crystal may be considered as an assembly of number of equidistant parallel sides and equidistant parallel planes. passing through the lattice points and are called as lattice plane. आपल्याला माहिती आहे लॅटिस पॉईंट्स जर आपण 3 डायरेक्शन जर कन्सिडर केला 3 डायरेक्शनला जर कन्सिडर केला then this represents the if you join these lattice points like this which are equidistant lattice points. If you join this represents the plane. This represents the plane. Equidistant plane, it means that these all are represents the planes. Similarly, if you join these lattice points, that will represent the equidistant parallel planes. It means that a crystal lattice may be considered as an assembly of number of equidistant parallel planes passing through the lattice points and are called as the lattice plane. These are called the lattice planes. Orientation of such plane in a crystal may be described in terms of intercept on the axis. For this, let us consider a plane. Suppose this is the crystallographic axis. Suppose this is x-axis, this is y-axis, and this is suppose z-axis. Now let us consider a plane. Suppose this is A, this is twice A, lattice parameter, that is lattice point, this is the A, this is B, this is twice B, and suppose this is C, this is twice C. Now let us consider like this plane. Now consider this is the plane. Okay, this is the plane. Now in this plane, the lattice point is along x-axis as twice A, along y-axis it is twice B, and along z-axis is at only C. Let's consider this is the plane. Now let us consider this is a point A, suppose this is point B and this is point C. Now this plane ABC, which has intercept 2 axes along 2 axial units along x-axis, 2 axial units along y-axis, and 1 axial units along z-axis. The numerical parameter of these faces are 2, 2 and 1. 2, 2 and 1. Therefore its orientation can be expressed as 2, 2, 1. These orientation are expressed as 2, 2, 1. However, according to Millar, it is more useful to describe the orientation of plane by the reciprocal of its numerical parameter rather than by its linear parameter. This represents the linear parameter. These are represents the linear parameter. But according to Millar, it is very useful to represent the orientation of plane by reciprocal of this numerical parameter rather than linear parameter. Okay, such parameters are called as Millar indices. Such parameters are called as Millar indices. Now there is some procedure for finding Millar indices of plane. That is indices of lattice planes. There are some methods. Let's consider what is the first that is त्याला आपण म्हणू rules or methods. First is find the intercepts x, y and z on the plane. Find the intercepts x, y and z of the plane on the three axes in terms of lattice constant A, B, C. Second rule is express them in terms of axial units. Express them in terms of axial units. Third is take the reciprocal of these numbers. Take the reciprocal of these axial units. That is, for example, suppose x along x-axis it is suppose P1A, along y-axis it is suppose P2B, and along z-axis it is suppose P3C. then to take the reciprocal of this, then the reciprocal of the axial units. Therefore axial units is P1, P2 and P3. These are the axial units, that is 1 upon P1, 1 upon P2 and 1 upon P3. These are the reciprocal of the axial units. Okay. And fourth is convert these reciprocals into whole number. If fraction arises, then convert these reciprocals into whole number by multiplying each with their least common multiplier, LCM, and put them in bracket. Put them in a bracket. That is, suppose L is the LCM, then this is the reciprocal of this numerical parameter. Therefore we can write L upon P1, L upon P2, L upon P3. This L upon P1 can be expressed as H, this L upon P2 can be expressed as K, and L upon P3 is expressed as L, and put them in a bracket, that is H, K, L. That represents the Millar indices of that plane. Millar indices of that plane. Now for this, for example, let's consider now this plane. Now according to, by adopting the rule, let's consider for this plane. For this plane, what is the first rule? Find the intercepts of x, y and z on the plane on the three axes in terms of their lattice constant ABC. Then what is the, according to first rule, what is the intercept along x axis? It is twice A. Along y axis it is twice B. Along z axis it is only C. Therefore first it is x equal to, that is x equal to twice A, y equal to twice B, and z equal to only C. Now second rule, express them in terms of axial units. Express them in terms of axial units. Now we have to express in terms of axial units directly, twice A, twice B, twice C. That is express in terms of, that is 2, here it is 2, and it is 1. That is axial units. Therefore now what is the third point? Take the reciprocal of axial units. Therefore here take the reciprocal of, second point is the third point, take the reciprocal 1 upon 2, this is 1 upon 2, and this is 1. This is the reciprocal of these axial units. And what is the fourth point? Convert their reciprocals in a whole number by multiplying each with their LCM. Now this is the fraction 0.5, 0.5, 1. Now if we multiply this number by 2, least common multiplier, then we get a whole number, that is 4. If we multiply it with 2, it means that 2 into 2, 2 into 1 by 2, that is equal to 1. Here also 2 into 1 by 2, that is equal to 1, and here equal to 2 into 1, that is equal to, that is whole number 1, 1, 2. It is represented by H, it can be represented by K, it can be represented by L. Therefore we get here H, K, L parameters as 1, 1, 1, 2. That is 1, 1, 2. This represents the Millar indices of this plane. Millar indices of this plane. 1, 1. Similarly, we can find out the Millar indices of any plane. Millar indices of any plane. Now consider a simple cubic structure. In a simple cubic structure. Now in simple cubic structure, we have to find out the Millar indices of plane in simple cubic structure. Now consider the simple cubic structure. Suppose this is the x-axis, this is y-axis, and this is the z-axis. Now this along the x-axis, this lattice parameter is A, this lattice parameter is B, lattice parameter is C. We know that in cubic crystal A equal to B equal to C. We know that is. Okay. Now we have to find out the Millar indices of this front plane. This front plane. We have to find out the Millar indices of this front plane. Now this Millar indices of this front plane, which is touch x-axis at distance a, at lattice parameter. It is the lattice point here. Along y-axis, this plane is parallel to the y-axis. It means that it do not intersect at x-axis, at y-axis. It do not intersect to the y-axis. Similarly, this plane is parallel to the z-axis. It means that it do not intersect to the z-axis also. Therefore, when the plane is parallel to one of the coordinate axes, whenever the plane is parallel to the coordinate axis, it is said to meet that axis at infinity. It means that this plane is touching the y-axis at infinity. This plane is touching the z-axis at infinity. This plane is touching the x-axis at point A, at A. This plane is touching the y-axis at infinity. This plane is touching the z-axis at infinity. Therefore, suppose this plane, suppose ये plane allow you upon A, B, C, D. Suppose that is the plane A, B, C, D. We have to find out the Millar indices of this plane A, B, C, D. Now we know that whenever the plane is parallel to some axis, it means that that plane touches that axis at infinity. At infinity. Therefore, the intercepts of this plane along x-axis is, that is 1a. Along x-axis is 1a. Along y-axis is, which is intersect at infinity, infinity b, and along z-axis it is also at infinity c. Now according to rule, take the reciprocal of the intercepts. That is, what are the intercepts? That is reciprocal of 1 upon 1, 1 upon infinity, 1 upon infinity. Now convert into, that is 1, 1 upon infinity, that is 0, 1 upon infinity, that is 0. Now put it into the parenthesis. Bracket मध्ये put करा, parenthesis मध्ये put करा. This will represent the Millar indices of this plane. That is, this plane represents the 1, 0, 0 plane. 1, 0, 0 plane. Similarly, consider another plane in simple cubic crystal. Now this is the simple cubic crystal. Now consider this plane. So this is the x-axis, this is y-axis, and this is z-axis. Now consider this plane. This plane. Now this plane, the point line of A, B, C, D. Now consider this plane A, B, C, D. This plane A, B, C, D. Now this plane, we can see that this plane is parallel to y-axis. This plane touches the x-axis at intercept A. Lattice parameter is A, lattice parameter is B, and lattice parameter is C. This plane touches x-axis at point at A, intercept A, along z-axis at intercept C, and along y-axis at, it is parallel to the y-axis, that is, it touches the y-axis at infinity according to rule. Therefore, we can directly find out the intercepts of this plane. Along x-axis it is 1a, along y-axis it is infinity b, and along z-axis it is 1c. 1c. Now the intercepts are 1, infinity, 1. Take the reciprocal of this, that is 1 upon 1, 1 upon infinity, and 1 upon 1. That is 1, 0, 1. That is, it means that this plane represents the 1, 0, 1 plane. That is, this plane represents the 1, 0, 1 plane. Put it into the parenthesis. That represents the indices of this particular plane. Now consider another plane in a simple cubic crystal. Suppose this is the plane, this is the simple cubic crystal. X-axis, y-axis, and this is z-axis. Now consider this plane. Let's say this plane. Now this plane, now do A, B, C. Now plane ABC. Now this plane touches the x-axis at A, along y-axis at B, and along z-axis at C. We are considering here the cubic crystal. It means that A equal to B equal to C. Okay. Therefore, the intercept of this plane along x-axis is 1A. Along y-axis it is 1B, and along z-axis it is 1C. Take the reciprocal of the intercepts, that is 1 upon 1, 1 upon 1, and 1 upon 1. Therefore 1, 1, 1. It means that this plane represents the plane 1, 1, 1. The Millar indices of this plane is 1, 1, 1. By using this method, you can find out the Millar indices of any plane.